Let's consider some more questions in C programming. What is the output of the following C program fragment? This is a C program fragment available over here. Now you have to produce the output of this particular program. Here you can see I assigned a value to this variable. Now what kind of value is this? This is treated as an hexadecimal value. When we place 0x in front of any value, then that value is treated as an hexadecimal value. Like if you place simply 0 in front of any value, it will be treated as an octal, as we had already learned in our previous lesson. In the similar way, if you place 0x in front of any value, then that value is treated as an hexadecimal value. Okay? Now, the format specifier for hexadecimal is %x. And if we try to print this out, this is going to be the answer. 43FF. Okay? Now, one thing that you need to note here is that you can either write 0 small x or 0 capital X. Both are one and the same thing. You can write small x or capital X over here. There is no difference between these two things. You can use any of them. Okay? You can also write small f or capital F also. There is no difference in that case. But yes, one thing that you need to note here is that if we change this small x to capital X over here as a format specifier, then the output printed would be 43 capital F capital F. Please note down this thing. Previously the output is 43 small f small f. In this case the output is 43 capital F capital F. So please be careful about such things. If you're using percentile capital X, then the output would be capital F capital F. And if you're using small x, then the output would be small f here in this case. Now as usual, if we change the format specifier to %d, then we need to convert hexadecimal to decimal, as we know this thing already. We learned this thing in our previous lesson already. If you want to convert this hexadecimal number to the decimal number, then we have to apply the same procedure that we did for the octal number. If you remember in our previous lecture, we already learned this thing, that how to convert an octal number to a decimal number. In the similar way, you have to convert an hexadecimal number to a decimal number. And here is the output for this particular program. 17407. This is the corresponding decimal value for this hexadecimal value, you can say. Let's consider the next question. What is the output of the following C program fragment? Let me tell you one thing, this is very important question. Okay, so please concentrate while I am giving you the answer for this question. First of all, you should check what is the output of this particular program. Is it 27? Is it 0? Is it no output? Or is it none of the above? In order to understand this question, you need to understand the memory layout of C program. This is the memory layout of C program. You might think of this thing that might be when the C program is compiled successfully, then it will get stored into one memory section. But in reality, different parts of the program will get stored in different sections of the memory. Let's try to understand what these all sections mean. Basically, there are two memory segments you have. The one is text segment or a code segment. This is the one. It is called text segment or a code segment, where the actual machine code of the compiled program is stored. Okay? And this section is read-only section. Let me tell you one thing. The another segment of the memory would be data segment. There are several parts of the data segment. Initialized segment, uninitialized segment, stack segment, and the last one is heap segment. Here you can see this is called initialized data segment, and it would consist of global variables, external variables, static variables, both local and global, and constant global variables as well. This initialized data segment would consist of all these different kinds of variables, you can say. That means when you define a static variable, that will get stored into this particular segment only. Now one more thing. This section would consist of two parts, basically read only and read write. There is a reason behind that. Initialized data segment would not only consist of global variables, external variables, and static variables, but also consist of constant global variables. Let me tell you one thing, constant global variables. We already know this thing. When we define a constant global variable, its value we won't be able to change in our code at any cost. That means it has to be in the read-only section, right? And the other variables must be in the read-write section. So there is no problem in understanding this point, right? Therefore, we have two sections for this initialized data segment. One is read-only and the other one is read-write. Now, what is the purpose of this uninitialized data segment, which is also known as BSS segment or block started by symbol segment? Okay. Uninitialized data segment would consist of uninitialized global, static, and constant global variables. The variable, if it is uninitialized, will get stored into this segment. Otherwise, the variable which is initialized will get stored into this segment. Variables such as global, extern, static, and constant global variables get stored inside this initialized data segment if they are initialized. That means if these variables have been provided with some initial value, they are getting stored inside this data segment. On the other hand, if suppose the variables are not initialized, then they are getting stored inside this uninitialized data segment, also called as BSS segment. Note down this full form also, block started by symbol. Important. Apart from this thing, we have stack segment and heap segment as well, but we are going to have a lot of discussion later on in the chapters when we're going to talk about pointers and recursion. Right now, our concern is these two segments only because we are talking about static in particular. And we know this thing, if static variable we declare and it is uninitialized, then it will get stored inside this uninitialized data segment. On the other hand, if the static variable is initialized with some value, then it gets stored inside this data segment. Now let's try to consider code of this particular question, and please try to understand this code very carefully. Here you can see in this program, we just have a main function, along with that a return 0 statement. My purpose of writing this code is to just make you understand what would be the size of the program. Okay, and we are going to check this out with the help of command prompt. We have to shift our attention to command prompt to understand what would be the size of the program. Let's move to the command prompt. Here you can see this is the command prompt window. This program question answer set3.c is stored inside this directory C programs. Now what I'm going to do is, I'm going to compile this code over here by writing a command in the command prompt. Please carefully observe the command. If you are using a GCC compiler, then this is the command you need to write. GCC, then space, then question answer set3.c, which is my file name, then space, then -o, then space, then question answer set3.exe. That is your executable. This is your source code and this is your executable. Okay, you simply hit enter. This simply means that your source code is now compiled successfully. If it produces any error, it will produce over here, but there is no error at all. Therefore, no problem. Now if you want to use this command successfully, compiler automatically comes with code blocks. If you want to use that compiler, which is available from the code blocks itself, then what you need to do is, you need to set the environment variable before using this command. Click on Windows C drive. Here you can see you have program files folder. The one is program files x86. Click on it. You find out a file code blocks. Click on it. Click on mingw. Then simply click on bin. Copy this path over here and click on this PC again. Right click. Click on properties. Choose advanced system settings. Click on environment variables. Now what you need to do is, search over here. You will find out a path variable, which is one of your system variables. What you need to do is click on this and click on edit. Here you need to add this particular path. Here you can see I have already added this, that is C drive, program files x86, code blocks, mingw bin, and then click on OK. Everything is applied successfully. Now you can use this command over here. Now if you want to know the size of your program, then what you need to do is simply type size, then space, then question answer set3.exe, which is my file name, and this is the executable. Then I simply hit enter. This would be the size. In the text segment, you will find out the size is 4360 bytes, and in data segment you will find out 940, which is actually your initialized data segment. In the BSS segment you will find out 96 bytes, and these three things are visible to you. Total size would be 5396 bytes, and this will be your file name, which is question answer set3.exe. Now let's change the code a little bit and let's check out the size once again. Here I declare a static variable outside in global scope, and let's see what would be the size of the file. We need to recompile this code once again by using the same command that I have written over here. If you don't want to type this command again and again, then you can click on the up arrow available in your keyboard and you will find out this command over here. Just simply click enter. This compiled successfully. Now we need to know the size of this file. Question answer set3.exe, I don't need to write this name again. What we need to do is to use an up arrow in the keyboard or down arrow, click on enter. You'll find out the size is quite changed, right? Here in this case, the BSS segment size previously was 96 bytes. Now it is 100 bytes. Why? There is a 4 bytes increment in the BSS segment because this static integer I variable is uninitialized. And this variable, we know this thing, is going to get stored into the BSS segment as we had already discussed, right? Therefore, this variable is getting stored inside this BSS segment, and that is why the size is increased. Data segment is as it is, text segment is as it is, but the size of BSS is increased as you can see. Okay, let me change the code a little bit over here. Now I'm going to explain you a very important point. Try to understand it very carefully. What I'm going to do is I'm going to initialize this variable with a value is equals to 0. This is the initialization step. We already know what is the meaning of initialization. When we provide value at the time of declaration itself, then that is called initialization, right? Therefore, I initialize this variable with value is equals to 0. As we know this thing, if we initialize the variable, then this will get stored into the data segment, right? And that is what we are expecting. So data segment size needs to be increased, right? Let's see what would be the size. Here again we need to recompile. Click on down arrow. You will find out the size question answer set3.exe. Hit enter. Now this is something that we need to know. Data segment size is as it is. If I initialize this variable, then this variable need to be stored into the data segment, right? And data segment size needs to be increased and BSS segment size needs to be reduced. But as you can see, BSS segment size is as it is. That means this variable is stored inside the BSS segment, even though we initialize it with value. Now this is an important point to note. When we initialize this variable, we are thinking about this thing that this will get stored into the data segment, right? But it is actually getting stored inside the BSS segment. Why is it getting stored inside the BSS segment? Now one thing that I would like to put here is that when we won't initialize any global variable, we already know this thing that it is by default initialized with value is equals to 0. If I simply write static int I and I won't initialize it with any value, then that will get stored inside the BSS segment, right? Apart from that, it is by default initialized with value is equals to 0. Now what is the change we are doing here? Here also we are initializing it with value is equals to 0. So what is going on internally is that this variable is also getting stored inside this BSS segment even though we initialize this value. Here we are not initializing any different value. We are initializing it with value is equals to 0. No difference. Therefore, this variable is getting stored inside the BSS segment only, and that is one of the most important point. Actually, this variable need to be stored inside the data segment because we initialize this variable with some value, but it is getting stored inside this BSS segment. That is the very important point we need to note. Okay, suppose we initialize with some different value other than 0 and save this code. Let me recompile it. Now the data segment size is increased while the BSS segment size is reduced. That means this variable now shifted to data segment because now we initialize it with some different value other than 0. Therefore, this particular variable gets stored inside the data segment and not inside the BSS segment. Okay, let's move to our question of concern. According to our question, these are the first two lines, right? First line here is a static int I and the next line is static int I and I initialize it with value is equal to 27. Let's try to understand this code. Here I am compiling this once again. And this would be the size. Because of this first line static int I, first it will get stored into the BSS segment, right? Then after that, when I declare another variable with the same name, when I initialize it with some value other than 0, this variable, because of the same name, this variable is transferred from BSS segment to data segment and the data segment size is getting increased and the BSS segment size decreased. This would be the third line, right? Okay, let's save the code and see what would be the changes. No changes at all. If you carefully observe this thing that data segment will be same and BSS segment would be same. This simply means that multiple times you can declare. There is no problem at all. You can write this statement multiple number of times even before or afterwards. Once you initialize, it will get stored into the data segment and you won't be able to initialize it further anymore. Suppose you write another value like 24, then this thing is something which is not allowed. If you try to execute this code, it will produce a compiler error. Let's see how it is producing a compiler error. Here you can see it is treated as a redefinition of I. Static int I is equals to 24. Previous definition of I was here. Static int I is equals to 27. Right? This is called as redefinition of a variable I. Because you initialized this variable previously, therefore you won't be able to initialize it further in the global scope with the same name. Please note down this thing. On the other hand, simply writing this thing is allowed. Totally allowed. Even though if we write something like this, I is equals to 0, and if we save the code and try to see what would be the output in this case, let's recompile the code. Then this is also treated as redefinition because this value is initialized by us and not by the BSS. Therefore, it is considered to be as a redefinition. Even though this variable is stored inside the BSS segment and we initialize it value is equals to 0, not the BSS. Therefore, if we try to initialize it once again, then that will be treated as a redefinition of I. Please don't do such things. Let's change this once again according to our question. Inside this main function, there is another variable, right? According to the question, which is static int I, right? And then after that, you have a printf function. Now we know this thing that scope rule comes in this case. Therefore, this I is preferred over to this I, or this I. When we initialize a variable, then that variable is the only variable stored into the data segment and the other variables are simply ignored, you can say, with the same name, right? This variable is stored inside the data segment. Even though if you write static int I, you might think like that way. After this will get updated to value is equals to 0, but this is not the case. Therefore, this variable is only available with us, which is the initialized one. Multiple number of times you write this statement, there is no difference. This value is not getting updated. Suppose this is not available with us. Then you know this thing that this I would be taken from this variable itself. If you try to execute this code, then this would be our output, right? 27. Because this is the variable which is inside the data segment and this is the variable which is available only. If we won't have this statement over here like static int I, then the output would be 27 only. And we can tick mark the A option if you remember that. Let me remove this comment. Now let's see what would be the output. Output is 0. Why? This variable is within this function only, right? As we know this thing that this variable is getting stored inside the BSS segment. If you want to know this thing, let me execute it within the command line. Let me recompile this code. You can see over here, previously it was 96. Now it is updated to 100, right? That means this variable is getting stored inside the BSS segment. And we know this thing that this variable get preference over to this variable, which is initialized 1. Therefore, the value printed over here is equals to 0 and not 27. Local variable get preference over to the global variable. We already know the scope rules. Therefore, the value printed is equals to 0 and not 27. Please note down this thing. Okay, let me change the code a little bit for fun's sake. Suppose I won't do any initialization, I simply do the assignment of the I variable. Let's see if this is allowed or not. This is redefinition of I. Why? Note down these warnings over here. Type defaults to int in declaration of I. Because compiler automatically put integer data type in front of a variable. Assignment is not allowed at the global declaration. Suppose we comment this particular statement and this statement as well. Instead of assignment done over here, we do assignment over here. Like I is equals to 45. Let's execute the code. It runs perfectly fine. Assignment is allowed within the function block only and not outside the function or any other function. Okay? In such global declarations, these assignments are not allowed. Compiler automatically puts integer in front of this variable. Therefore, this variable is treated as an integer variable and the whole thing is considered to be as a redefinition. You already defined this variable over here and you're trying to define another variable with the same name. Now this is considered to be as a redefinition. Now you understand this thing that why these variables are by default initialized with value is equals to 0. Because they are stored inside the BSS segment, and inside the BSS segment by default these variables are initialized with 0 value. Not only the static variables, all the global variables, static variables and constant global variables are initialized with value is equals to 0, except the extern variable, right? Static int I, when we simply write it down, it is getting stored inside the BSS segment, and by default this variable is initialized with value is equals to 0 if we won't initialize it. Okay? Apart from this, such type of assignments are not allowed, and this is very important. When we write static int I is equals to 0, then that variable gets stored inside the BSS segment only. And if we try to initialize it once again, then we won't be able to do that, because that initialization of 0 is done by us and not inside the BSS segment by default. Therefore, it is considered to be as a redefinition. If we change this code according to our question, then let's see what would be the output. Output is 0. Therefore, we can say option B is correct, right? Okay friends, this is it for now. See you in the next lecture. Bye bye.